If you haven't already, I would like you to try this worksheet before watching this video. But if you get stuck on some of them or you just need a little more guidance, then you can just watch it. You could also try one and then watch the video and kind of pause. Totally up to you. So first, our armory of aardvarks question. So with this problem, if I multiply by 2y and by dx on both sides, I'm going to end up with 2y dy equals 3x squared plus 1 dx. Now I can integrate, and I'll get y squared equals 3x cubed over 3, which is x cubed plus x plus c. And now here I could wait to plug in my values, but I'm going to plug them in now because I feel like it, I guess, but you could do later if you want. Okay, so then our y is 4, so then 4 squared equals 2 cubed plus 2 plus c. So 16 is 8 plus 2 plus c. That's 10. So c is 6. So now we have y squared equals x cubed plus x plus 6. So then our final step is to square root both sides. So y equals the square root of x cubed plus x plus 6. So keep in mind that it could have been a positive or a negative square root, but I know that my y value up here is positive. So this function, the square root, has to be positive. Bevy of quail. So if we multiply by dx on both sides and divide by y squared, we get dy over y squared. And if I'm going too fast as far as that goes, feel free to stop by office hours and be like, wait, you're skipping too many steps for me. So we get dy over y squared equals 6 minus 2x dx. This is the same as y to the negative second dy equals 6 minus 2x dx. And then we integrate, of course. And we get y to the negative first divided by negative 1, which will just make it negative, equals 6x minus 2x squared over 2, which is x squared, plus c. So this is negative 1 over y equals negative x squared plus 6x plus c. I'm going to evaluate now, okay? And so, actually, you know what? There's nothing to evaluate, right? There's no point. So we just need to solve. So let's see. I'm going to multiply by y, and so then I have negative 1 equals negative x squared plus 6x plus c times y. And then if I divide by negative x squared plus 6x plus c, I end up with y equals negative 1 over negative x squared plus 6x plus c as my general solution. It's general because we don't have a specific point to make it more, well, specific. Convocation of eagles. All right, I'm going to multiply by dx. I'll kind of show a middle step here. So I'll have dy equals y over x squared. Should we do it this way? Yeah, dy equals y over x squared dx. You know what, actually, this isn't looking nice, and we could do it this way, but instead let's cross multiply, and we have y dx equals x squared dy. Well, we can't divide by y, right? Because, or dy rather, because then we have a dy in the bottom, and that's bizarre. But we can divide by y, and then we have dx equals x squared dy over y. And then we can divide by x squared, and we get dx over x squared equals dy over y. I'm going to flip-flop the spots, right? So dy over y equals dx over x squared. And it turns out there's really no great way to get to this. It takes some manipulation as far as cross-multiplying or just multiplying by dx or whatever you want. But let's integrate this. So technically this is the integral of 1 over y dy equals the integral of x to the negative second dx, just rewriting so we can integrate more easily. Integral of 1 over y is the natural log of the absolute value of y. Integral of x to the negative second is x to the negative first over negative 1, which is just negative x to the negative first, plus c. Let's see. We could evaluate now. I'm going to keep going though, partly because I can see that I would end up with a natural log of 3 if I did it now. So I'm going to exponentiate both sides. So I end up with y equals e to the negative 1 over x. Might as well write it that way now instead of negative x to the negative first, plus c. If you recall, whenever we do this, this is just like this plus c. It's like an e to the c, so we move it out front, okay? So y equals c e to the negative 1 over x. And so now we're really close, but I'm going to put in my point, which is 1, 3. So then 3 equals c e to the negative 1 over 1. So 3 equals c e to the negative first power. E to the negative first is like 1 over e to the first. So 3 equals c over e, and c is 3e, which just sounds like some, made up number, but we can do it. And so then if we kind of go back here, we end up with, for our equation, we had this, but now we can write it as, or I'm sorry, we had this, right? That's as far as we got to. So now we can write this as y equals 3e, that's instead of c, e to the negative 1 over x. Okay, this is a lot, right? So 3e, that's technically to the first. Exponent rules, we can add the powers, so we actually get y equals 3e to the 1 minus 1 over x. How fun was that? Does it get any better? No, definitely not, huh? I'm going to leave Drove of Donkey for you guys to do. Should we do this one? Yeah, this is a good one to do, mostly as a reminder that if you look at it and think like, I can't split these up, well, we kind of can, right? Because we can factor. And so dy dx actually equals 4y times 1 minus 2x. And now I can split them, right? I can divide by 4y and I get dy over 4y equals 1 minus 2x. I can multiply by my dx. And so this is 1/4 times 1 over y dy equals 1 minus 2x dx. I'm going to leave the 1/4 outside and integrate. You can do it whichever way you want, right? So this is 1/4 natural log of the absolute value of y. And you could have done u substitution and done u equals 4y if you wanted to, and you'll get the same answer even if it looks a little different, equals x minus 2x squared over 2, which is x squared, plus c. Okay, well, let's multiply by 4, okay? Because I have 1/4 natural log of y multiplied by 4. And so I'll get, let's see, natural log of y equals 4x minus 4x squared. And honestly, 4 times c is 4 times a constant. It's just a different constant, so I'm still just going to call it c. And then I'm going to exponentiate both sides. So then y equals e to the 4x minus 4x squared plus c, but that's really just e to the c, so we'll do y equals c e to the 4x minus 4x squared. And the big thing is if you left the plus c up there in the power, that's fine, but you'll see it out front in front of the e in a multiple choice answer. Okay, so I'm just going to start this next one for you, partly because I'm out of space and partly because you guys can do it. But start by thinking y times 1 plus x squared plus dy dx equals 0. And then if you subtract y times 1 minus x squared, we get dy dx equals negative y times 1 plus x squared. And you can totally do the rest of it. You can check the key. Let's see. This is a good one to do together. The gaggle of geese problem. So dy dx equals 2y x sine of x squared. All right, I'm going to divide by 2y and multiply by dy dx. So I'll have dy over 2y equals x sine of x squared. I'm just going to put that in parentheses so we remember it looks like that, dx. And then we will integrate. So this is like 1/2 times the integral of 1 over y dy. We've seen things like this. Over on the right here, we're going to do chain rule. And so if we do that, I think I'm actually just going to kind of, this is however you guys want to do it, honestly, but I'm going to bring it down here and say the integral of x sine of x squared dx. So u would be x squared. Du is 2x dx. dx is du over 2x. So then we'll have x sine of u times du over 2x. X's cancel, so we have the integral of 1/2 sine of u du, which is, let's see, derivative of cosine is negative sine, so derivative of negative cosine is going to be sine, so we get negative 1/2. We get negative 1/2 cosine of u plus c. So when we go back up here, instead of u, we're going to put our x squared back in. So this integral here is going to equal negative 1/2 cosine of x squared plus c. But what's the value of this integral? 1/2 natural log of, 1/2 natural log of y equals negative 1/2 cosine of x squared plus c. Well, I can honestly multiply everything by 2 and the fractions are gone, right? So I have natural log of y equals negative cosine of x squared plus c. Exponentiate both sides. Y equals e to the negative cosine of x squared plus c. But this plus c turns into e to the c and goes out front. So y equals c e to the negative cosine of x squared. I will show you this last one, hover of trout. I don't know why I said it like that. Y prime is 8y. Y prime is the same as dy dx. I'm just going to divide by the 8. No, I'm not. I'm going to divide by the y, right? And multiply by the dx. So I have dy over y equals 8 dx. Then we integrate. Dy over y is like 1 over y times dy. So we end up with natural log of y equals 8x plus c. Exponentiate. So we get y equals e to the 8x plus c, but that plus c is like e to the c. So y equals c e to the 8x. And we could have, as soon as we integrated and got to this step, we could have evaluated it 1, 2, but I waited till now and that's fine too. So then we know that if y equals c e to the 8x, then 2 equals c e to the 8 times 1. So 2 equals c e to the 8th. So then c is lovely, right? 2 over e to the 8th. Again, really ugly, but it totally works. So then our answer, instead of c e to the 8x, is y equals 2 over e to the 8th times e to the 8x. And that's it. And my key is really messy here. The one posted in this folder is better. And again, finish this one, do this one on your own, check your answers with the key.